In this lesson, we're going to take a look at solving a parallel circuit in which the two resistors are in parallel with the power supply. So we're going to first draw the circuit. It says that we have a 20-volt battery. So let's go ahead and draw that. So our battery we'll put over here on the left. And we'll label it with 20 volts. And it has a switch, a 4 ohm resistor, an 8 ohm resistor, and an ammeter in each one of the lines. So let's go ahead. We'll first put a switch in. We'll make our first line and put an ammeter in the line. A resistor. And then we'll come back and we'll put another ammeter in the line with the power supply. So that is one loop. A parallel circuit has more than one loop, so we'll put another loop parallel to the first. Put a resistor in there and connect it. And now when current is going through the line, it has a couple different ways it can go. So the current comes down the line this way, and here it can go to the right, or it can go downwards. So this is what we mean when we say a parallel circuit. We're not done yet though. They ask us to, let's label this. So we have our 20 volts. We have a 4 ohm resistor here. And then we have an 8 ohm resistor here. And they ask us to put a voltmeter on each one of the resistors. So we'll put a voltmeter here, and we'll put another voltmeter right here. And this will tell us all the information we need about our circuit. So let's go ahead and figure out what the total resistance of our circuit is. Total resistance for parallel circuits is 1 over Req, so 1 over the equivalent resistance, and it's equal to 1 over R1 plus 1 over R2. So that's equal to 1 over 4 ohms plus 1 over 8 ohms. And that's going to be equal to an Req of 2.67 ohms. Let me just double check on that. Yes. Okay. So now that we have that part set, let's go ahead and take a look at the potential difference across the 8 ohm resistor. Now, when you're looking at parallel circuits, all the potential difference in each one of the lines parallel to each other is always the same. So we start with a 20 volt potential difference at our source. So it's 20 volts in the 8 ohm resistor. It's also 20 volts in the line with the 4 ohm resistor. So they all have the same exact voltage. And now let's take a look at the current. So the current at the power supply, we're going to use Ohm's law. Voltage is equal to current times resistance. And here we have a voltage of 20 volts. The current we're trying to find, and this is the current in the line that's passing through the power supply. But then we have our total resistance, which is 2.67 ohms. And if we calculate that, we can find that the total current here, 20 divided by 2.67, will give us 7.5 amps. And now we want to find out what the current is in the 4 ohm resistor. So here we can use Ohm's law again. Voltage is equal to current times resistance. And here we have 20 volts, has the same voltage as our power supply. Our current is what we're trying to find. And the resistance in the 4 ohm line is 4 ohms. So 20 divided by 4 will give us 5 amps. Then finally we have the current in the 8 ohm resistor. That is, voltage is equal to current times resistance. 20 volts. We're trying to find the current. And then we have 8 ohms of resistance. And that gives us a current of 2.5 amps. And here's how we solve a problem for a parallel circuit.